Okay, so I'm only going to teach half of 3-8 today, and we'll do the other half tomorrow. So we're going to purely talk about parallel lines and how to write their equations and what their slopes are. So as you look at your review information, look at it. Line B is what to line A? What did you say? Perpendicular is correct. And then what about line B is what to the x-axis? It is parallel. And then line A is what to the y-axis? Parallel also. And then the x-axis to the y-axis? Perpendicular. Very good. And then you have your converse, your inverse, and your contrapositive. They started the first half for you, and you had to do the second half, which they should not have had to start the first half for you, right? You should already know what those are. So if the sum of the measures of the angles of a polygon is 180 degrees, then the polygon is a triangle. True or false? True. The inverse, if a polygon is not a triangle, then the sum of the measures of its angles is not 180 degrees. True or false? That is true. Because if it's not a triangle, then it doesn't have three sides, and it doesn't have three angles, it's not a contrapositive. If the sum of the measures of the angles of a polygon is not 180 degrees, then the polygon is not a triangle. True or false? True or false? True. So all of those are true. Then we come to the word for today, and really this word is for tomorrow, because this is for our second half of our lesson, but the word reciprocal. We are going to use a reciprocal in conjunction with finding perpendicular lines. So the definition is really that the product of the two numbers equal 1. So the reciprocal of one number versus another, if we multiply those two numbers together, we have a product of 1. All right, so let's look at the problems for today. I really don't care if you complete this top part, to be honest. All right, so let's look at our key concepts. If two non-vertical lines are parallel, so vertical means that they would look like this. So if they're non-vertical and they're parallel, they might look like that, then their slopes are equal. Aren't these going in the same direction, and aren't they at the same inclination, the same angle, if you will, to the x-axis? And so their slopes are equal. If the slopes of two distinct non-vertical lines are equal, then the lines are parallel. Aren't these just converse of each other? Or what are they? Is it just saying really the same thing, it just paraphrased a little bit differently? It's not even a converse. So these are saying the same thing. Any two vertical lines or horizontal lines are parallel. Why? Vertical lines all have what slope? Undefined slope. Don't say no slope, right? Undefined slope. And horizontal lines have what slope? Zero slope. So they have the same slopes. Now, horizontal and vertical lines are not parallel to each other. What are they instead? They're perpendicular to each other. So for 10 and 11, I want you to circle the correct answer, whichever statement is true. So here your answer is there. Number 10, a vertical line is parallel to any other vertical line. This one we said was what? Not parallel, but so to correct this one, it would have to be perpendicular. And for number 11, any two non-vertical lines that are parallel have the same slope. The key word is that are parallel. And that's what this one's missing. I could have two non-vertical lines that are not parallel, they would look like that. That's why the top one is not correct. Then for problem 1, which we're going to do some on our own, For problem 1, you're checking to see if you have parallel lines and or you are writing the equations of a line that's parallel to a line of both. So they've kind of walked through this a little bit with you. We're going to do some on your own, completely on your own. But look what they gave you. Line 3 contains points A and B. So line 3 contains point A and B. And then line 4 contains C and D. And they want to know, is line 3 and line 4 parallel? So in order to figure out if they're parallel, what do we have to know first? We have to find their slopes. So that's the very first thing we're going to do is find slopes. So I'm going to let this be x sub 1, y sub 1, x sub 2, y sub 2. Is that fuzzy or clear to y'all? Is it clear? Are you positive? Because it looks awfully fuzzy. That's got to be a smidge clear, maybe not. All right, good enough for us. All right, so then to determine if the lines are parallel, we have to check to see if they have the same slope. So you're going to see us finding the slope. So here's your slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You're supposed to know that formula. And here they're applying it. They're taking y sub 2, which is 2, and they're subtracting y sub 1, which is 6. Then they take x sub 2, which is negative 1, and they are subtracting x sub 1, which is negative 13. So take care of any double signs. And we get 2 minus 6 is negative 4. Negative 1 plus a positive 13 is positive 12. So what does that give you? Negative 1/3. Then we're going to look at the slope of line 4. So you go ahead and find that slope. I want you to get in that habit of using the template. So write out those subtraction signs first before you plug in your numbers, and then make sure that you label these. X sub 1, y sub 1, x sub 2, y sub 2. And then you find the slope. And then answer questions 14 and 15. So compare your answer with those around you. See if they agree. Ryan, talk to us. Yes. All right, so what did we come up with for a slope? What did we get? 1/3? Is that the same as negative 1/3? No. So are they parallel? No. Their signs have to be the same. So the slopes are equal, that's no. And are lines 3 and 4 parallel? No. Because the signs of these slopes are not the same. It's not enough to have the same number, the same value, 1/3, but their signs have to be the same. So this slope over here in pink is going to the left because that would be a negatively sloped line. And then this slope here in blue is going to the right because that would be a positively sloped line. They are actually not perpendicular. They'll look more like this. And we'll find out more about perpendicular lines tomorrow. So we good with that? Questions on that? All right, so then look at problem 2. So they want to know what is an equation of a line parallel to y equals negative x minus 7. So that's not the line that we're seeking. Negative x minus 7 is a line that is parallel to the line we want to find. there are an innumerable amount of lines that are parallel to negative x minus 7. I could spend an eternity to find them all. So they have to tell you a point that your line goes through, and this is what they do. So you're playing detective. The first thing, the reason why they're giving you this line right here is so that you can see what the slope is to your line. Because when we write the equation of lines, we are going to use y minus y sub 1 equals m times x minus x sub 1. I will always substitute in a point, so x sub 1, y sub 1, and the slope. So in order to write the equation of any line, I have to have a point and a slope. Well, look at what they've given you. They've given you a point and a way to find the slope. They've kindly solved this equation for y for you. They put it into slope-intercept form so that you can see the slope. What is the slope of this line here? The coefficient is -1, so the slope of that line is -1. What is the parallel slope to -1? It's a trick question. It's also -1, so isn't that the slope of your line? So I have a slope, and then this is x sub 1, y sub 1. So now all we're going to do is plug and chug. So we're going to, we want a slope that's -1. That's our slope. And then we're going to plug into our formula. We already wrote our formula above, m times x minus x sub 1. And then they're plugging in. So again, here's our values that we're plugging in for. So I like to write my template first. And then plug in that value second. So they already put in the 3 for us. We're going to put in our -1 for a slope. You can just put a negative if you want to. And then our y, though, is -5. And this is why I like to put in my template first, because oftentimes y'all just put x minus 5 instead of x minus -5. And really what should be inside is a positive 5. So take care of any double signs. It's an x plus 5. You want to distribute that -1. You cannot add or subtract this value here until you have cleared parentheses on the right-hand side. So when I distribute that -1, I get a negative x. -1 times a positive 5 is a -5. Then we want to add 3 to both sides. And we end up with y equals a -x. A -5 and a positive 3 is a -2. So look at your final 2 lines. So this is a line that ours is parallel to, and this is our line. Notice how they have the same slope, but different y-intercepts. If they have the same slope and the same y-intercept, then aren't they the same line? It's not parallel, it's just the same line. So you're looking for different y-intercepts with the same slope. Question on that. All right, so take out your workbook. Let's look at page 87 in your workbook. You might need some additional paper for this. So if you write really small, you might be able to fit it in here. Mr. Ruby would be good at that. He's my champion at getting someone with all of my page. All right, so let's look at questions 1 and 2 first and foremost. I'm going to start with 2. You cannot look, this is page 87 in your workbook. So it should be practice 3, page 87. You cannot just look at this and say, oh yeah, they're parallel. You have to prove it. So what I want to see from you is stair-stepping on your line. So you're going to make a rise and a run. You're going to make a stair-step. Make a right triangle. How far, and you can do it above or below. So you could have chosen, on this one, you could choose to go below. So if we went below, our stair-step would be going this direction. It doesn't matter whether you go above or below. If I rise from here to here, how far is that? 1, is it positive 1 or negative 1? Positive 1. And my run from here to here is how far? 4, when I'm going to the right, is that a positive direction or a negative direction? Positive. So my slope for this line is rise over run. So slope is equal to rise over run. You have to rise up out of bed before you run and go to the bathroom. That's the first thing you usually do in the morning, right? What happens if you go to the bathroom before you rise out of bed? You wet the bed. So you must rise, and some of you fall out of bed, right? So rising includes a negative direction of falling out of bed. And then you either run to the right or the left, the bathroom, one of the two. And so that's how you can remember. I don't want to pee my bed, so rise up first or down. So we're going to rise up 1 to the right 4, and that simplifies to 4. So that doesn't change. This one, if I go in this direction, if I go down 1, isn't that a negative 1? And I'm going to the left, 1, 2, 3, 4. Left is a negative direction on the equipment grid. So my slope here is a negative 1 over a negative 4, which does reduce to a positive 1/4. Are the slopes equal? Yes. So because of that work, then you can say that yes. Our lines are M sub 1 is parallel to M sub 2. I don't like the fact that they use an M for name of line here, but I'm not in charge. So then I want you to find 1. So do number 1 on your own. Show your stair step. Go above or below the line, but then give me the points that you can stair step from. You choose any nice whole integer points. When you get an answer, I want you to compare with a friend. So compare yes or no, and what are your slopes? You should not be using your math for this. You should purely be stair-stepping and counting squares. You should not be using slope formula. You can check your answers with slope formula, but I'd be stair-stepping. All right, so what'd you get, yes or no? No. Visually, you'll all agree that it's not, correct? But you have to have the work to support it because this is wider here than this is here. So visually, they don't look parallel. You got to double check it. The slope of line M sub 2 is negative 2, and the slope of line M sub 1 turns out to be negative 5/2, so they're definitely not the same. So your answer is no. M sub 1 is, I guess we could go not, parallel to M sub 2. So that's easy to tell. Then we're going to do questions 3, 5, and 6. I'm going to do 3 with you, and you're going to do 5 and 6 on your own. Actually, maybe I'll do 5 with you. Got a fraction. So I'll do 5 with you, and then you'll do 3 and 6 on your own. Don't let it bother you. First of all, I hate this. What do I hate about that? I hate mixed numbers. We don't use mixed numbers in equations. Now, is it nice to look at the mixed number for graphing purposes? Of course. But we don't use mixed numbers other than for equals. So I don't like that either. Number 2, all I care about in this line, my line is parallel to this one. This is not our line. So I want to know what is the slope of this line. Is it 1/5 or is it 8 4/5? It's the coefficient of x, right? So the slope of this line is 1/5. What is the parallel slope? It's also 1/5. That will change tomorrow. And so then I want to use this point. This is x sub 1, y sub 1. we're going to run it through a formula. Y minus equals x minus. Let's root it in. So my y sub 1 is 6. My slope is positive 1/5. And my x sub 1 is 3. So we've got this ugly fraction here. Don't let that bother you. We've done this before. So we have to distribute the 1/5 before we can add the 6. So we've got y minus 6 equals 1/5 times x is 1/5 x. And then a positive times a negative is a negative. 3 over 1 times 1 over 5, nothing cancels. We get 3 over 5. So here's the problem. When I am adding 6 to both sides, so I want to add a 6, but it's 6 over 1, correct? What's my like denominator between the 5 and the 1? They both have to be 5. So this one needs to be multiplied by 5, and this needs to be multiplied by 5. So I end up with a, right here I have a negative 3/5, and this gives me a positive 30 over 5. Don't reduce. So I have a negative 3/5 and a positive 30 over 5. What does that give you? 27, subtract, right? 27 over 5. So my final answer is kind of ugly. Y equals 1/5 x, and it's positive because the 35 is bigger than negative 3/5. So positive 27 over 5. Notice how both lines have the same coefficient for x, and they should. So that was ugly because of the fraction. So then I want you to do 3, and I want you to do 6 then. Yes?
How did you get parallel slope in the beginning? How did you get parallel?
They told you that the line is parallel to AB, and so in the directions, I already know that they're parallel because they told me. They're either going to tell you it's perpendicular or parallel, so today they should all be parallel for all your homework assignment. All right, so you go ahead and do 3 and 6, and you do about 5 minutes to do that. You might have to do them on a separate sheet of paper. A surprise ending to one of them. I'll come around and help. judge, you gotta ask for help.
That's why I never do share.
Yep. So, ladies and gentlemen, there's a couple of you in here that have chosen to do nothing. But as I just start coming along and look, now we're gonna work. These are choices that you make as a student. So if you choose to sit and not take notes, or you choose to sit and not do your problems, that should be there. Then that's your choice. You're making a bad choice. It has no variance whatsoever. The student, oh, it's just, yep. If we have zero, we're not going to. Yep. And then it's not how you. Right. Unless there's one. Right. The only time it'll make a difference is if it shows out to be the line, because it shows up one goes on the line, then maybe going, okay, we're not sure. Okay, so I'm going to put the answers up here. So here's number 3. So as you start with number 3, the line that they gave you, this number means nothing to you right now. Other than when you get down to your final answer, if these are the same numbers, then you have the same line, not a parallel line. So right now, it doesn't matter what that y-intercept is. It has no bearing on the problem at all. All you need is to take the slope from this line, and that slope is -5. Your parallel slope is the same slope. So we're using -5 as our slope. This is my x sub 1, my y sub 1. Make sure that you put them in their correct places. Take care of any double signs. Don't leave a minus minus, because oftentimes you make a sign error because you're looking at a negative. And so that becomes a positive. When you distribute that -5, watch your signs. You get a -5x here, but a negative times a positive makes that a -10, not a positive 10. So if you had an 11 here, you had a sign error. And so when you go and add that 1 to both sides to solve, this becomes a -9 rather than that positive 11. And then this one actually turned out quite nicely. You didn't have to deal with the fractions if you were looking for reducing fractions. So again, this means nothing. You're focusing purely on the coefficient in front of the x term. So the slope of that line is -2/5. Your parallel slope is the same exact slope. You can use that. There's your x sub 1, your y sub 1. So this time you have your double negatives on the y side. So change those to plus plus. You have a -5 here and a negative slope out front this time, so be careful. When you distribute that -2/5, you get a -2x, or -2/5 times x gives you a -2/5 x. And negative times a negative is a positive. This is 5 over 1. Don't those 5's cancel? Doesn't it become a positive 2? So some of you here had -2 times -5 is positive 10 over 5 times 1 is 5. So you had 10 over 5. But 10 over 5 reduces to 2. Use that reduced fraction form. I'd rather deal with non-fractions than I would fractions any day. And so then all you have to do is subtract 2. Well, those 2's cancel here. Don't write a plus 0, because we don't want that. We want just this equation, y equals -2/5 x. And so if you look at the 2 original equations, they have the same slope. What's the y-intercept of the second line? Where's it across the y-axis? 0. The origin, right? Any questions on that? Because that's pretty much what your homework's going to be. A couple of goofy questions to cause you to think. But for the most part, that's what your homework is. Issues, problems, concerns. Okay.